Okay. This is some picture of the external facade implemented in the cubic. After the coffee break or before the lunch, we will visit Cubic. Cubic is an infrastructure to testing materials and systems related to energy efficiency in buildings, to improve them, to evaluate them, and so on. So the lighting system, the external facade and the internal facade are implemented in the cubic. So then you will have the opportunity to see them. In the future, we would like to test also the smart window facade, so the reversible window. But now we have 3 of these technologies applied in cubic. So the main objective of this, as I said before, the main objective of this solution is to improve the existing solutions in the market to have a high-performance envelope. So our idea is to mix the vacuum insulation panel with a ventilated facade, reducing the thickness and improving the U value of the facade. So, as you know, there are several conventional insulation materials like rock wool, polyurethane, polyethylene, based on foam, mineral wools, fibers, and even materials such as cork, hemp, and perlite. There are huge materials to insulate your facade. But in this case, the thermal conductivities of these materials are between 0.045 to 0.032 watts per meter per Kelvin. So this material not so good for the insulation. You need a big thickness to achieve the U value that the Commission is requesting nowadays. In this graphic, you can see the value of the vacuum insulation panel compared to the rest one. So it's a good material to use in the construction sector, but it's true that this material is not very common nowadays. So in order to reduce the U requirements, we need to increase the insulation thickness. And this is one of the challenges of this project, to reduce the thickness of the envelope. We would like to share with you sentences that we have identified. The vacuum insulation panels can define as an evacuated foil encapsulated open porous material as a high-performance thermal insulating material. This material is 3 to 6 times better than steel hair. And this vacuum is encapsulated with a microporous material. With this material, we can achieve high thermal energy resistance with a low thickness. But it's important to take into account also the cost of the material. So in this graphic, we can see the general prices of each of the insulation materials related to the thickness. So in the first, we can see the vacuum insulation panels. We don't have lists. No, okay, no problem. We can see in the first column the vacuum insulation panels. That is one of the most promised insulation for retrofitting. So why we have developed these technologies and why we want to reduce the thickness? Because the Commission, when the approval of the APBD recast, the thickness of the insulation has almost doubled. So nowadays we have more strict requirements for the U value of the wall. So in this table, you have more or less the different U value of different countries, and the U value are between 0.18 and 0.4. So we need a good insulation to achieve these values. This is the reason we selected the vacuum insulation panels as the best solution to retrofit buildings by the external facade or by the internal facade. And for example, in this table, you can see different thickness using different insulation. Rock wool, EPS, super insulation, and vacuum insulation panels. So with the vacuum insulation panels, with 4 centimeters of this material, we achieve a U value of 0.16.
Is this commercially available now?
Yes, we have the industrial partner here with us, Íñigo and Andrew. Then after me, Andrew will present the internal solution, and maybe he can you can talk with them during the coffee break. But it's true that the application in the construction wall is not so common. The common application is more for fridge, refrigerators, and also
transport, freezers,
yes,
more static and smaller scale.
because nowadays the price of, for example, rock wool is more competitive, but you have to take into account not only the first investment. You have to take into account other kind of things, the space that you save with this kind of solutions. So for us, the use of this technology and material is a challenge. So we have achieved this challenge, and we think that we achieved the scope of the project. The main design features of these technologies is a summary of these the different components of the external facade. We have the big panels protected by rubber, because although all the components are commercially available, we have to improve all of them. The beams have been improved with this rubber. A new development by Bergamo, the PVC clips to support the vacuum insulation panels. We have the aluminium anchorage, thermal pad, aluminium T-profile, pier insulation, and claddings. So with these solutions, we can achieve a U value, as I said before, of 0.276, including I don't remember the name, but the linear thermal transmittance of the linear thermal breaches and the punctual thermal transmittance of the 3D thermal breaches. I mean, in the construction wall, sometimes when you calculate the U value, you don't the people don't take into account the linear thermal transmittance and the punctual thermal transmittance. But in this project, we have taken into account everything. So this value could be better if you calculate without this kind of thermal breaches. We have kept the hydrothermal properties of the ventilated facade, and the final solution protrudes only 10 centimeters to the exterior. So the total facade is the thickness of the total facade is it's not very big. So it's not a problem, for example, there are some streets with problems if you increase the facade with 20 or 30 centimeters. So with this solution, we can solve many problems. So we have 5 components: the beams panels with these dimensions, thickness, and protection. the PVC clips, the additional insulation material, because in some parts of the facade it's more cost effective to use the PIR material than the insulation. The supporting structure, aluminum profiles and T profiles, and the cladding. You can see the big panels with the rubber protection. The PV clips. The clips are 3D printed and extruded clips to support vehicle insulation panels on the demonstration wall, and Bergamo has developed different type of clips until achieve the best one. So now the solution, the clip has been improved, and now is a good one. At the beginning we had some problems to support because the wind and so on, and this is the reason we have installed the facade in cubic to test the mechanical condition of the whole facade, and to prove each element in real conditions before installing the final solution into the real demo buildings. The PIR insulation, we use this insulation in the vertical unions between BIP and BIP. Then we can see, we will see in the prototype installation and also in cubic. Supporting structure. The green area is the protecting area, the thermal pad that we have mentioned before. And the last component is the cladding. In this case, because of their hydrothermal properties compared to open joint solutions, we decided to use extruded ceramic panels with overlap joints. In this case, these solutions is very flexible, and we can select different dimensions to apply in different buildings, and also you can select different colors for different buildings. One of the questions that we will answer is the applicability of these solutions. From our point of view, it is designed to be implemented in all the type of buildings, like a common ventilated facade. So it's not a critical point. It's true that for historic building, the solution cannot be applied, but for this kind of building, we have the other the next technology, the insulation, the internal facade solution, and the thermal conductivity. Well, as I said before, the benefits of this solution is a very high performance solutions. The system is very easy to install. You can save floor space in the building, and the system can be incorporated with existing and future elements. We are not going to explain in depth all the evaluation that we have developed in the frame of the project, but it's true that we will say with you, we would like to share with you the different performance that we have verified. We have verified thermal performance, one-dimensional U value according to this regulation, 2 and 3 dimensions U value when considering multidimensional heat transfer, the solar heat gains coefficient. These points related to thermal performance. Then we have developed different condensation performance that was one of the critical points of the vehicle insulation panel, the condensation and interstitial condensation. So we have developed evaluation related to indoor surface condensation and mold growth risk, and also interstitial condensation. And finally, of course, we develop overall mechanical performance of the facade. And once all the results of these points were satisfactory, we followed with the real demo sites. So it's a continuous process to improve these solutions. It's another comparison to achieve the U global. As I said mentioned before, we have taken into account linear thermal transmittance and punctual thermal transmittance, and finally we have the U global of the facade. No condensations.